Good morning and welcome back to another day of we're not in algebra, we're in geometry. And today we're going to be working on lesson 5.1.3, and we get to learn a very important concept today called inverse trigonometry, something that has been used very seldomly so far in our mathematical journey. And so the big picture today is, how do you find the missing angle in a right triangle? All this time so far we've been finding the side lengths in a right triangle. So how do we go backwards and find the missing angle? And so the backdrop for this work is going to start on problem number 24. And it says, Mr. Gao needs to build a wheelchair access ramp for the school's auditorium. The ramp must rise a total of 3 feet to get from the ground to the entrance of the building. In order to follow the state building code, the angle formed by the ramp and the ground cannot exceed 4.76 degrees. So as the direction says here, Mr. Gao has plans from the planning department that will call for the ramp to start 25 feet away from the building. It says, draw an appropriate diagram. Will this ramp meet the building code? So in order to figure this out, this thing is going to be 25 feet away, and this is going to be 3 feet above the ground. And so we can create a right triangle, something that looks like this. Will it meet the state building code? I don't know. We don't know what this angle is, this angle of elevation that we're looking at. And so it says to find an angle in part B from a trig ratio, you need to undo it, just like you undo addition with subtraction, multiplication or division, or by squaring and finding a square root. So these are all example pairs of what we call inverse operations. So when you use a calculator to do this, you use inverse trig functions that are labeled like this. These are pronounced inverse sine, inverse cosine, and inverse tangent, and those should be found on your calculator. So when you're doing this work, what you're going to do on your calculator is you're going to press the second button, and then after that, you're going to press the sine button. And so on your graphing calculator, if you press second sine, what that's going to do is that is going to do the inverse sine for you, which will help you find an angle measurement. So it says verify that your calculator can find the inverse trig value when using the triangle at the right. So when you do this, which trig ratio should we use? Well, this is the adjacent leg to the 60 degrees, and this is the hypotenuse. So adjacent divided by hypotenuse is cosine. So if we do, just like the directions say here, the inverse cosine of 8 over 16, your calculator should tell you 60 degrees. Again, we need to make sure that we are in not in radian mode rather, but that we are in degree mode. So if you are unclear or have questions on something like that, please reach out, but you should be in degree mode and you should be getting 60 degrees. So now it says, return back to your diagram from part A. According to the plan, what angle will the ramp make with the ground? So as I look back here, if this is the angle I'm trying to determine, okay, we need to make sure that that is built to code. This leg here would be the adjacent leg to that angle, and this leg here would be the opposite side. So what trig ratio uses opposite and adjacent? Opposite and adjacent is used by the tangent function, or the tangent ratio. So what I'm going to do then for part C down here, in order to determine my work, I know that the tangent of some angle is equal to the opposite leg divided by the adjacent leg. And so in my current diagram, I don't know the angle. However, I do know that the leg opposite that angle was 3 feet and the adjacent side was 25 feet. So how we go about solving this problem now is we take the inverse tangent of both sides. And when we do that, these essentially cancel each other out. And so I'm left with theta, which remember is just an angle. It's the variable that we use for an angle, is equal to the inverse tangent of 3 over 25. And this is where you'd type into your calculator inverse tangent of 3 over 25. So you'd press second tan, and then you'd probably want to do 3 divided by 25. And when you do that, you should end up getting 6.84. Oofta, this is tough. struggling. 6.84 degrees. And so to answer the question, will the ramp be to code? No, it will not be to code. It exceeds the 4.7, what was it, 4.79, I believe, 4.76. So that angle is too steep. So it says at least how far from the building must the ramp start in order to meet the code in Part D. And so Part D is now asking, hey, well, if this is 4.76 degrees and this is still going to be 3 feet, how long will this need to be? So this is going the other way. This is going back to what we did beforehand. So if you need to determine now what is the length, when we're finding a side length, that's where we're going to actually use the tangent ratio again. But in this case, I know what my angle is. It's 4.76. I'm not trying to find the angle. I'm now trying to find a side length. And so this goes back to how we've solved several problems already. I'd cross multiply x times the tangent of 4.76 degrees equals 3, and then divide both sides by the tangent of 4.76. So you get 3 divided by the tangent of 4.76, and then you end up with roughly 36.21 feet. So in this introduction slide, we can work backwards to find angles right here by using this new thing called inverse trigonometry. And it works for inverse sine, inverse cosine, inverse tangent. So if we have a ratio of sides that involves one of those three ratios, we can find the angle by using this idea called inverse. And we'll practice that on the next couple of slides. On number 25, it says, hey, find the measure of angle A and the measure of angle B. Once you found the first acute angle, what knowledge about the angles in the triangles could you use to help find the second one? Well, as I'm first going to do, you can find either A or B to begin with. I'm going to start by trying to find the measure of angle B. It doesn't matter if you used A or B, but if I am trying to find the measure of angle B to begin with, then the ratio of sides that I have is this one and this one, and so this length of 14 would be opposite the side or the angle of B, and so then this 15 is the hypotenuse, and the fact that it's across from the 90 degrees. So what trig ratio uses the opposite in the hypotenuse? Well, that would be the sine function. The sine of theta is equal to the opposite leg divided by the hypotenuse. So in my current situation, I don't know what theta is, so the sine of theta is equal to, now the opposite leg is 14, hypotenuse is 15. So in order to determine now what my angle is, this is again where we would take the inverse sine of both sides. So I would get that theta, which remember is just my angle, it's just a variable that we use for the angle, is equal to the inverse sine of 14 over 15. So this inverse sine is really the operation that we're doing, like undoing multiplication. That cancels this operation of sine out, but whatever I do to one side, I also do to the other side. I do the inverse sine of both sides. So then I type that into my calculator, and when I do that, I get that theta is roughly, for the measure of angle B, are about 69 degrees. And so once I know that this is 69 degrees up here, let's use some common sense. I know two angles in a triangle, so I can find the third angle right here pretty easily from the triangle sum theorem. I know that all three angles in a triangle should add up to 180. I know a 90-degree angle, and I now know a 69-degree angle. So I can subtract those three all together, and I should end up, for the measure of angle A, with 21 degrees. But again, using this idea of inverse trig to help us to be able to find a missing angle in a right triangle. All right, on number 26, what I want to be able to, again, do is just highlight the fact that these are the ratios that we've dealt with in terms of trigonometry, and these allow us to be able to find now either angles or missing sides within a right triangle. So on number 26, there's three triangles, and I would encourage you to draw them on your paper. It says, look through all the triangles first and see if they look familiar, or ones that you know how to answer right away without using a trig tool. Then for the other ones, identify which tool should be used and find that missing variable. What I want to highlight to begin with is this one, letter B. notice both of these side lengths are 8. And if you have two sides of a right triangle that are the same, that means that this angle right here has to be 45 degrees, as does this one right here. That's an isosceles triangle. And so both the side lengths are the same, and those other acute angles are both 45 degrees. Now for letter A, this is going to go back to what we were just practicing. I'm trying to determine an angle, and since I'm trying to find an angle, I know that I'm going to use inverse trig. Inverse trig and finding angles go hand in hand. And if this is my angle of reference up here, that makes this leg, the adjacent leg, it's immediately next to it. And this leg right here is the hypotenuse, as that's across from your 90 degrees. So what trig ratio uses the hypotenuse and the adjacent leg? That's where I go back up here. Cosine uses the ratio of the adjacent and the hypotenuse. So again, I'm going to set up the cosine of theta is equal to the adjacent leg divided by the hypotenuse, that ratio. And so what I can fill in my work, I can say the cosine of theta is equal to 12 over 24. And now in order to get theta by itself, I take the inverse cosine of both sides. And so my work looks like this then. Inverse cosine of 12 over 24, and you type that into your number cruncher, and you should end up getting 60 degrees. So that angle is 60 degrees, which if you wanted to find the other angle in that triangle, it would be 30 degrees. But again, using the inverse cosine in order to determine that. And then on letter C over here, notice I have an angle, excuse me, and I'm trying to determine this length. So I'm not going to be using inverse trig in this one. Okay, don't get yourself so focused on this. I'm not using inverse trig on this one because I have an angle and I'm trying to determine a side length. So in this instance, if this is my angle, the side length across from it now is going to be the opposite. This is the hypotenuse. So what ratio uses opposite and hypotenuse? That would be sine. So I'm going to set up an equation using sine. The sine of theta is equal to the opposite over the hypotenuse leg. So I can say then that the sine of 57 degrees is going to be equal to 7 over x. And so now we go back to solve like we've done the last couple of days. Put this over 1, cross multiply. We're going to be left with 7 equals x times the sine of 57 degrees. And you type, don't type that in your calculator yet because we still need to solve for x. So I'm going to divide both sides by the sine of 57 degrees in order to get x all alone. And in doing so, now you're going to have x all by itself. And x is equal to 7 divided by the sine of 57. And so now this is the thing that you type into your number cruncher. And you should end up getting roughly 8.35 for your length of x. This last problem is just kind of a more broad idea that some students encounter. It says Peter cannot figure out what he did wrong. He wrote the equation below to find the missing angle of a triangle. However, his calculator gives him an error message each time he tries to calculate the angle. And this might happen to you. So he typed this in, and so in his calculator he typed in the inverse cosine of 8 divided by 2.736, and so it said an error. Your cosine ratio is impossible, Jerry said. And so what they mean by that, if cosine of some angle, whoopsie, I didn't write that very well. Cosine of theta is the ratio of the adjacent leg to the hypotenuse. What we should notice right now is that the adjacent leg is currently longer than the hypotenuse. And that can't take place. That's not possible in a right triangle for the adjacent leg to be longer than that of the hypotenuse. And so therefore this angle does not exist because that triangle does not exist. And so therefore that will not work since the hypotenuse is always the longest side of a right triangle and the denominator is always bigger than 1 when we're dealing with the cosine and the sine ratio. So this only is true for sine or cosine. Just wanted to highlight that. Again, recapping today, we just learned how to find an angle by using this sine, inverse cosine, and inverse tangent feature on our calculator. If you have questions, stop by office hours. Otherwise, stay safe and stay healthy, and we will see you soon.